Okay, good evening, class. We are welcome to our chemistry class for the evening. So, today we'll be talking about air and air pollution. Under this topic, we'll be focusing on the composition of air, importance of air, other consequences of air, and air pollution. So, these are the things we'll be taking today. So, um, we all do know that here as we can see, but we feel the effects of air. So, what is air? Now, air is defined as a mixture of gases composed mainly of nitrogen, oxygen, carbon dioxide, noble gases, and water vapor. So, the point is that unlike other substances that are compounds, air is a mixture. And we do know that one beautiful characteristic of mixtures is the fact that they can be separated through physical means. So, what are the evidences to prove that air is actually a mixture? The first is that the constituents can be separated through physical means. That is, these gases that make up, oh sorry, these gases that make up air, oxygen, nitrogen, and the others. When we try to separate them, we do not need to use chemical means. We don't need to use chemical techniques. All we need to use is physical means. And well, this is actually carried out when we are trying to get oxygen or nitrogen that is being stored for other use. Excuse me. For us to actually get these gases, we have to separate the mixture, that is air itself,
Nahima,
using.
sorry, Nahima, could you mute your mic? I don't know. Okay, yes, good. Now you can also off your camera to reduce the quantity of the MB, your data consumption. Do you know how to do that? Just by the side where you see mute, you see start video, just click on it. Okay, you can go ahead, sir.
Okay. So so for us to get out this constituent, like say oxygen, we use physical means, which is fractional distillation of air. We separate it. Actually, that is a very different topic on its own. But the point is, for us to get this individual component for them to be useful for other things, we separate using physical means. Now that's the first thing. Now the second thing is, despite the fact that all of these gases come together to form this mixture, they all still hold their individual physical and chemical properties. In that whole mixture, you can identify oxygen, you can identify nitrogen, you can identify the rare gases because they still hold on to their particular characteristics. They do not mix up together and then you cannot now say, oh, okay, this is oxygen, this is nitrogen. No. Even as they are in that mixture of air, they can be identified by their different properties. Now the other one is that if appropriate portions of each constituent are mixed, there will be no evidence of chemical combination. Say, for example, you bring out oxygen and say you want to mix it only with nitrogen. It will still be oxygen and nitrogen. It will not form a different compound that is just there and there. It will not form a different compound. It will still be that mixture. No matter how you combine it, it will still be constituents of air because they are mixed through physical combination. There is no chemical reaction there. And the last is that composition of air cannot be represented by chemical formula. There is no textbook, there is no place online that if you Google, say, chemical formula of air, that you say, okay, this is the chemical formula. No, there's nothing like that. It's just a mixture of different gases. So what you might see is the different gases in their different relative proportions. So that's that for the evidences to prove that air is a mixture. Now, in this picture, we have a representation of the different constituents of air and their relative percentages. Now we have nitrogen there having 78%, oxygen 21%, carbon dioxide or carbon dioxide 0.4%, and other gases, mostly argon, 0.96%. Now, these percentages vary with different locations. Say, for example, for people living in urban areas where we have companies and large factories that are emitting a lot of chemicals into the atmosphere, the percentage of the other gases there will be relatively high compared to oxygen and the other things. So, and they're now comparing that with a rural area where there are no companies, there are no factories, just people living scantily, and say in that place they have a lot of trees. We know that the trees will be giving off high amount of oxygen. Now, still comparing that with a place there in the north, like up north, where it's close to the desert, we have no much trees, but we have more humans there and animals. You would know that in that kind of a place, the percentage of carbon dioxide or carbon dioxide will be higher there. So the relative composition of air differs from one place to the other based on the biological and chemical activities that are taking place in that particular area. But the most important thing is that nitrogen has the highest percent, followed by oxygen, and then sulfur, and then the other gases follow suit. And the most common of these rare gases is argon. Now, let's move to the importance of air. Air is very, very necessary. In fact, for the existence of man, plants, animals, air is of utmost importance. But here we're talking about the four or let's say three major importance of air, which is cellular respiration, burning, and rusting. So we'll start with burning. What is burning? Or let's say what we are talking over here is actually combustion. Combustion actually is defined as burning of a substance in the presence of oxygen. But since we say it is in a mixture, you cannot just bring out the oxygen on its own. So it's, you can still say it is burning of a substance in the presence of air. Now, whenever this happens, it is accompanied by heat and light. Now, during a reaction, combustible materials react with oxygen in the air and form oxides and other products. For example, we have candles. Um, Candle is formed for or is a product of hydrocarbon. We do know that it is one of the products of crude oil, which is the major source of hydrocarbon. Now, when candle burns, when it is lit, what happens is it begins to melt, right? And it begins to vaporize and it decomposes. Now, as it's decomposing, what we are having there as it is burning, we are actually having this hydrocarbon breaking down to form the hydrogen and the carbon. Now, when this combines with the air, the products will become carbon dioxide and water. Now, this is the same thing that happens with our gas cookers at home. Now, the gas you have in your cylinders, which is called uh, liquefied petroleum gas, is actually made up of the combination of propane and butane. We'll talk about this when we are talking basically on hydrocarbons. Now, these propane and butane are hydrocarbons, and when it burns, what you have is actually the release of or the breakdown of this hydrocarbon to form the hydrogen and carbon. When it now reacts with the oxygen, what you now have is water, which is given up as vapor, um, carbon dioxide, and obviously heat and light that we get from it. Now, there is something that still happens. In our generators, you use petrol. Petrol is also a product of hydrocarbons. However, the gas produced by the generator is carbon monoxide or carbon two oxide. Why? Because there is incomplete combustion. So when there's complete combustion, that's when we have water and carbon four oxide. But when there is incomplete combustion, we have carbon monoxide and water. And that is why it is very, very dangerous, very, very dangerous to put on your generator inside your room. Actually, it leads to death. Now, next is corrosion, or what we know as rusting. Corrosion results from the combined action of atmospheric oxygen and water, and it's faster in the presence of carbon dioxide and other gaseous pollutants like sulfur dioxide. Now, the point is this: in areas where we have factories and large companies, corrosion or rusting happens faster there because the air has been polluted with sulfur dioxide, possibly nitrogen, a high concentration of nitrogen and the other. So when these combine with the water in the atmosphere, which is your vapor, and the atmospheric oxygen, it will lead to corrosion or what we call rusting. Now, when iron rust, it combines with oxygen in presence of water to form brown hydrated iron 3 oxide. This brown hydrated iron 3 oxide is actually what we see when a product or when a metal has gotten rusted. It's brown, it has holes, it has pores, it breaks easily. Now, this is a chemical reaction to show how this happens. Now, we have Fe there, the solid ion, reacts with oxygen and water molecule there. We now have 2Fe2O3, which is your the dot XH2O represents the water that is now present in the ion, and to this water that has resulted into the rusting. Obviously, we know some ways to prevent rusting, like um, painting the iron with electroplating. Also have coating it, and also this to actually shield the iron from the atmospheric uh, water and oxygen. Now, what is the diffusion process? They involve oxygen. But I think for us, the rusting takes a longer period of time. It requires water, and burning does not require. We do know that when you have water, it actually notice the material has actually gone, has actually rusted. But burning is a very rapid process. 7 seconds, some material is completely burnt. Now, another thing about rusting is it gives out small amount of heat over a very long period of time. But for burning, it gives a large amount of heat over a very, very short period of time. For rusting, it must involve iron. It must involve iron. But for burning, involves many different type of materials. We have wood, we have plastic, we have paper, and you can actually still burn iron. It can be burnt. That's how it melts. So these are the differences between rusting and burning. They are both similar processes because they both require oxygen, they both release heat and all, but then these are the differences. Now, let's talk about respiration. Respiration is a process living organisms use oxygen to break down glucose to release energy. What eating, say you've eaten rice and you're about to get into some task, some work. What your body does is it breaks down these food you've taken in the presence of oxygen to give water, give out carbon dioxide and energy. Now, this happens animals. That process takes breaking down the sugar, the carbohydrates you've taken, presence of oxygen, because you do know that you breathe in oxygen and this is supplied to the lungs and there it now reacts to this food to give out the energy. So the point is, without the oxygen, the respiration will not take place. Also mean that when there is low amount of oxygen, respiration is very slow, possibly not possible. Now, what about photosynthesis? Photosynthesis is a process whereby green plants manufacture their food from manufacture carbohydrates from atmospheric carbon dioxide and water. Now, we do see there a reverse. Now, we the animals give out water and carbon dioxide. Now, this water and carbon dioxide is what the plants take in to produce the required food, and oxygen is still given up. Now, we still see that oxygen is still important here because it is a byproduct. Yes, it is. However, it's still in the entire combination. Now, other what we talk about nitrogen. Gaseous nitrogen is relatively inactive. It's more like we notice that it is 78%. It kind of just weighs down or puts a load on the air itself, makes it a bit heavy. Why is this important? It acts as a diluent to slow down corrosion and combustion. Now, the point is where there is low amount of nitrogen in the air, there will be faster corrosion and burning will be very, very fast. In fact, research has shown that in the absence of oxygen, if someone lights a cigarette, the cigarette will explode. And even the earth itself would have gotten burnt out in the absence of nitrogen. So nitrogen puts weight and reduces the effect of oxygen. Oxygen speeds, as we know, corrosion and speeds combustion, but nitrogen slows this down. This is as in plants to help them grow well, useless in soil, proteinous plants, which still assist us or helps us, you know, to help build our body systems properly. So nitrogen is very, very important, and it's even beautiful that it's advantage there in the atmosphere. Now, what about the noble gases? Some noble gases such as helium, krypton, and the rest like that, they are the most abundant in the atmosphere. Yeah, sorry, they're actually abundant in the atmosphere. However, argon is the most abundant. Now, argon is used filled lamps to prevent oxidation of the filament. So you have a lamp that has filament. What argon does is it will prevent it from burning off quickly. That's what argon will do there. Now, for others like krypton and xenon, they are used in photographers' flash tube for taking pictures. They help to bring out the light. But one thing these rare gases are good for is that they they produce a lot of light. Yes, they produce a lot of light. That's one thing about these rare gases. And say helium, neon, and argon are used in advertisement signs. We've heard of neon bulbs, or we've heard of like this neon glow and other things like that. There are some beads that people use and things like that produce light. Yeah, things like that, like these bulbs. Yes, they are the ones that have these gases inside of it. That's how they're able to produce those lights that we see. And even in our airports, we see these people that help to control the airplanes, having these kind of like sticks that have glow to wave the plane. So these aerodrome beacons too, they have these gases in them that help to give out the light. And then we do know, we have heard of this helium balloons, these big balloons that people um, get into and it goes up and they keep pumping it and it flies up very high into the air. Now, the gas that helps to make this balloon go up high is helium. Helium is quite light, so it actually does a good job of lifting the balloon. So these are some of the other consequences. Now we still have water vapor. Yes, water vapor is present in the atmosphere due to evaporation from water bodies. Daytime, when the sun is high and hot, evaporation is taking place on the ground, and the water goes up, condenses in the clouds, comes back as rain. So this water that goes up is the water vapor, and it still comes back as dew early in the morning when the saturation is not too much, doesn't come back as dew. But when there's high saturation of this vapor, the vapor pressure is high and it has condensed very well. That's what we have it as rainfall. So it is the vapor that has been gathered from the soil, from the water bodies, from your rivers, from your houses, from your wells, that has gone up to form this water vapor that makes up part of the constituents of air. Now, the presence of water vapor can be shown using the liquescent substances such as calcium chloride. When we're talking about acid base and salt, or concentrate on salt, we would discuss the liquescent substances. Now, these substances, what they do is when they react with water or water vapor, they dissolve to form solution. So when you have something like this calcium chloride and you put it and you expose it to the air, it will react with the water vapor that is present there and it will dissolve. So this proves that water vapor is actually present in the atmosphere. And for every atmosphere, there's actually a degree of water vapor there. And where the pressure of water vapor exceeds the saturation pressure, we have dew or fog, which can be formed, and formation of larger droplets results in rain, as we have said earlier on. So these are the things that make up this air. So we have seen that there is none of them that is of least important. They're all important despite their different percentages. Nitrogen there acting as a weighing balance or kind of like putting pressure on oxygen to reduce combustion and rusting and still helps to provide the nitrogen needed by the plants and also we ourselves we need this nitrogen to build our proteins in our body system. And we also have the oxygen there that is necessary for combustion, necessary for rusting, also necessary for respiration that helps us to get energy. I've seen water vapor here. If the water vapor is not there, we will not really have rain. We won't have the mist that comes up early in the morning. We won't have the dew that helps to wet the plants when there's actually no rain. So and we've talked about the rare gases that are used for example, helium used in the balloon, and those are used for lights and other things. In fact, we notice that in fact the bulbs that have these uh, gases, these rare gases are actually cost effective and they actually work quite well nowadays. Now, let's talk about air pollution. What is air pollution? Air pollution takes place where air is made impure by the presence of harmful substances, a concentration that can cause injury to humans, animals, and even plants, even possible to those that are even in the water body. So, where there is a high concentration of harmful substances in the atmosphere, that is air pollution. Now, these are a few causes of air pollution: tiny solids. These tiny solids are like dust particles that are found in the atmosphere or found in the air. When they are there, some of them can even cause blindness. Understand? And it causes or leads to low visibility. If we've been in areas whereby, say, there was kind of like heavy breeze, and maybe the place has very light sand and everywhere gets dusty. We know our visibility there will be quite low, and these dust particles can actually cause eye irritation and other things like that. Now, oxides of carbon, like your carbon dioxide and your carbon monoxide, these two can actually be sources of air pollution. Why? Let's talk about carbon dioxide. Now, one thing about carbon dioxide is that in areas where there is high concentration of carbon dioxide, that kind of place would experience a very, very high amount of heat because what carbon dioxide, one property of carbon dioxide is that it is quite heavy, and in the atmosphere, it kind of blocks air. I won't say air, like kind of makes everywhere hot, kind of trap. Yes, the word is it traps heat. That's what carbon dioxide does. Carbon dioxide traps heat. So when there's a high amount of carbon dioxide in the atmosphere, it will trap heat there and that place will be hot. That's why if you've ever taken note, in places where we have a lot of trees, that kind of place is usually cool. But where you don't really have trees, it's quite hot. Can say in your environment. I know this weather has been kind of relatively hot. So say you are walking under the sun and there are no trees where you are. If you compare the temperature there to when you just walk briefly under a tree, notice under that tree will be relatively cold. Why? We do know that trees require carbon dioxide. So when they take this carbon dioxide and release oxygen, which is actually a cool gas, actually makes the atmosphere around that place cold. So, so that's one thing about carbon dioxide. It traps heat, which is not really good. Now, what about carbon monoxide? Carbon monoxide is a very dangerous gas. Carbon monoxide, when it gets into the human system, what it does is it competes with oxygen in your system. And when it competes with oxygen in your system, just about 100 parts in 1 million leads to death. That's why I don't know if we've heard of the past news of families that slept and all died because there was a generator that was all inside their room or in their house. One thing about carbon monoxide is that it doesn't have smell. So it's, in fact, it just kills gradually and the person doesn't even know. It just reduces the amount of oxygen in the system till the person goes off completely. So that's for oxides of carbon. They can be quite dangerous based on their percentage in the atmosphere. Now, oxides of sulfur and nitrogen. These oxides are what causes what we call acid rain. And we have this majorly in industrialized areas where we have factories that are releasing gases into the atmosphere. But these gases, some are not careful enough to filter out these gases properly. So what they release into the atmosphere is sulfur, some nitrogen, and all. And when this goes up and, and later on, the water vapor condenses and wants to come back as rain. When it drops on our roofs and our ceiling, what we have is all of these chemicals coming down to us and gives us what we call acid rain. And if we know about acid rain, It's dangerous to the skin, dangerous to plant, dangerous to animals. In fact, it's the effect of this is seen this starting from the roofs where they touch. Quick um, rusting is what we'll notice when that happens. Now, gaseous hydrocarbon and chlorofluorocarbon. This is another very serious cause of air pollution. Gaseous hydrocarbon coming from vehicles and machineries that are producing these gases. When they go up into the atmosphere too, they are quite dangerous. And these chlorofluorocarbons are what causes the ozone depletion and what have you, the global warming, yes, although the carbon dioxide is part of it, but these are actually part of the things that still causes global warming, and they are also part of what we call the greenhouse gases, yes, the methane and all, they are greenhouse gases. Now, one thing about methane is that um, methane is produced sometimes from animal, oh yeah, major animal waste from cow dung, your chicken feces and all, when they start decomposing, they produce methane gas. Now, when you do not have, or when they do not undergo combustion, when they are not broken down to form your carbon dioxide and water, these gases go up in the atmosphere and leads to part of what we call the global warming. And this is why plants are quite very, very important because the plants would have actually helped to break this down, but well, they are not really there sometimes in our environment. So these are actually the causes of air pollution. Now, what are the precautions that can be taken to reduce this? We have things like strict laws can be put in place for companies to make sure they properly filter off or um, purify these gases before they release them to the atmosphere. Um, Indiscriminate burning of refuse and the others should be reduced. Um, Also, the use of factories, no, not like machines, some use of some machines should be actually reduced. And even in our environments, when we use our cars, our vehicles, there is actually a way to moderate how much of this is released. Like when cars are in traffic, turning off the engine can actually help to reduce carbon monoxide level in the atmosphere. So, this is what we'll take on this topic. Please, if there are any questions, we'll take questions now. Is there any question? Okay, if there are no questions, I think I can ask questions then. So my first question would be, which gas actually slows down the effect of oxygen when it comes to burning and rusting? I don't get a volunteer, I'll call anybody to answer. Okay. Eniola, which gas slows down the effect of oxygen? Okay, Eniola is not ready to give us answer. Who is going to help her out? Please let's see that we actually understood our class for today. Okay, so if you are not answered, please, if we do have questions, we can forward our questions later on to boss, and questions will be forwarded and we can actually answer, but we can still go through to go in material later to check up what we do not understand. Still open for questions, please. Okay. Erudite, you can unmute, please. Jared Erudite, you can unmute, please, and ask your question before the class is over. Okay. No, this is not coming up. You can send me your question later. Okay, yeah.
Please,
Yeah.
I want to corruption and roasting the same thing, sir.
Yes, it is the same thing.
All metal undergo corrosion.
Rusting is okay. The thing is that rusting is specific for iron. Rusting is specific for iron. Now, this corrosion is more of like a general name for the process that they all undergo. However, rusting is specific for corrosion.
Okay, sir.
Oh, rusting is specific for iron. Sorry.
Okay, and does all metal undergo corrosion, sir?
Well, there are actually